Welcome you back for the session on the actuating devices and the different types of DCV valves. Actuating devices. As we know, the DCV valves to be actuated for the flow of the fluid, or it may be a pneumatic. Here in this case, what we are discussing is with respect to the fluids, or it may be the oils. The actuation is a method of the moving the valve element from one position to the another. There are four basic methods of actuation. Normally, either it may be a manually, mechanically, solenoid operated, and as well as a pilot operated. Several combinations of the actuations are possible using these four basic methods. The graphical and as well as symbolical representation of these actuation and as well as the actuating methods are represented in the table in the next further slides. First, we are discussing the different types of the different types, or it may be the basic methods of the actuation system, and then afterwards we are going how the symbolically it is represented. Manually operated. Most of the very small DCV valves are operated by means of the manually, or manual operated is very easier. If the spool is to be shifted by manual movement, a handle or the push buttons, or it may be a step on a foot pedal is used. When the handle is not operated, the spool returns to the original position by means of the spring. The mechanically operated. The spool shifting by means of the linkages such as the cams and as well as the rollers, or even by means of the levers. The solenoid operated. The solenoid operated is a method in which it is operated by means of the electrical coil. The electrical coil is energized. It creates a magnetic force that pushes, or it may pulls the armature into the coil, by which the opening and as well as the closing of the ports can be done. This causes the armature to push the spool or the valve. The pilot operated DCV valves. The pilot operated DCV valves can also be shifted by applying a pilot signal against the piston at either end of the valve or the spool. When the pilot pressure is introduced, it pushes the piston to shift the spool. The symbolical representation with respect to the different types of the valves. If the solenoid valves or solenoid method of the operating is used, then the two rectangles with a horizontal rectangle with an inclined line we are using, that is nothing but the representation of the solenoid operation. If it is by means of the pilot operated, a small triangle, it should be represented in the side of the rectangle. If it's a manual operated, means two rectangles will be there. To the side of the rectangle, another horizontal rectangle will be there. For that rectangle, a lever will be represented, which is nothing but something like a manually operated. If the push button means the same, for the same thing, a knob type or a semicircular push button, it will be represented. If the same thing is by means of the foot, a lever with a foot pedal, it will be represented. In some cases, 2 or 3 different methods are applied. In such cases, the pilot operated and as well as solenoid operated means, in those cases, a triangle along with an inclined line, it is represented. A two position detent, in that case, the lever will be there, and also on the left side, a small projection, something like a pinion, rack and pinion type movement, that it will be there. The next one is nothing but a spring return. In that case, a knob type which will be represented towards the right side, and the spring it will be represented towards the left side. See, these are the different types of symbolical representation normally what we are using in the case of the hydraulic circuits. First, what we are discussing is with respect to the check valves. See, the DCV check valves is a very simplest one, or it is represented by means of a Y shaped with a circular round shaped with a horizontal line. It is a two-way valve because it contains the two ports, both in the forward direction and as well as as in the reverse direction. but the free flow will be in the forward direction, and the no flow will be in the reverse direction. The figure shows the graphical and as well as a symbolical representation of the check valve along with a no flow and as well as a free flow direction. The first what we are discussing is with respect to the ball type check valve. The figure shown below is a light spring loaded ball against the wall seating. The flow coming into the inlet that pushes the ball from the seat against by means of a light force of the spring and continues to the outlet. A very low pressure is required to hold the valve open in this direction. If the flow tries to enter in the opposite direction, the pressure pushes the ball against the seat and the flow cannot be passes through in the reverse direction. The schematic diagram shows the ball type check valve. In the ball type check valve, a ball will be there. A ball along with a spring movement will be there. The spring will pressurize the ball towards the left side. If the flow it has to be there from the inlet to the outlet, because of the pressure a gap will be created in the wall seating and the fluid will start passing from the inlet to the outlet. If there is any back pressure, the same pressure if it is developed means that it is acting against the ball, by which automatically it is closing the system, and the reverse flow it is not possible in this case. Poppet check valve. The figure shows the two schematic diagram showing the operation of the poppet check valve. A poppet is a special shaped plug type element that holds in the valve seat by a light spring. A fluid flows through the wall in the space between the seat and as well as the poppet. In the free flow direction, the fluid pressure overcomes the spring force, and in the flow is attempted in the opposite direction. The fluid pressure pushes the poppet in the closed position, and there is no flow is permitted. See, this one is a schematic diagram of the poppet check valve. The first one is under the closed position, and the second one is under the open position. The left side will be the inlet, and as well as the right side will be the outlet. Instead of a ball type one, here in this case a poppet type element is being placed. This poppet is pressurized by means of the spring. Once if the pressure is more from the inlet that pushes the poppet against the spring pressure, and the oil or the fluid will try to escape. Once if there is any back pressure from in the reverse direction, that pressure is applying on the poppet, by which automatically the closing of the inlet valve is taking place, by which the reverse flow is not at all possible. The advantages of the poppet valve: the virtually zero leakage is in closed position. The poppet element do not sticks even left under the pressure for a longer period. The fast, consistent and as well as a response is timely. The disadvantages of the poppet valves: the axial pressure balance is impossible, and a considerable force may be needed to open the poppet against the flow at high pressures. This limits the valve that have a direct mechanical actuation to the flow directions. Generally, the individual poppets are required for each flow path. That significantly increases the complexity and as well as the multi-port valve. The lapping and as well as super finishing of the valves added to the cost of the poppet valve.